Good afternoon, everybody. I want to discuss with you today regarding osmosis and the laws of osmotic pressure. Before going to the topic, I want to tell you here the difference between diffusion and osmosis. In case of diffusion, gas molecules or solution moves from higher concentration to lower concentration. In case of diffusion, the gas molecules or the solution moves from higher concentration to lower concentration. Whereas in case of osmosis, the solution moves from lower concentration to higher concentration through a semi-permeable membrane. I want to repeat the line once again. In case of osmosis, the solution moves from lower concentration to higher concentration through a semi-permeable membrane. Now, let me explain you what is the meaning of semi-permeable membrane. If you compare a semi-permeable membrane with an ordinary filter paper, here in case of ordinary filter paper, if you pour urine, you will get the same urine in the filtrate. If I shall pour urine through an ordinary filter paper, you will get the same urine in the filtrate. If you pour blood, you will get the same blood in the filtrate. If you pour ink, the ordinary filter paper, you will get the same ink in the filtrate. This is the case of ordinary filter paper. By pouring urine, you will get urine in the filtrate. By pouring blood, you will get blood in the filtrate. By pouring ink, you will get ink in the filtrate paper, Now, in case of a semi-permeable membrane, if you pour urine, you will get pure water in the filtrate. If you pour blood, you will get syrupy liquid in the filtrate. If you pour ink, you will get water in the filtrate. By pouring urine, you will get pure water in the filtrate. By pouring blood, the red blood corpuscles will remain in the residue and the syrupy liquid will go to the filtrate. By pouring ink, you will get water in the filtrate and the ink tablets in the particle form will remain in the residue. Is it clear to you the difference between ordinary filter paper and semi-permeable membrane? In case of ordinary filter paper, it allows the size of the hole or pores are as such, as big, because it allows both solute and a solvent to pass through it. But in case of a semi-permeable membrane, the solute will not be allowed to pass, whereas only the solvent molecules can pass through it. In case of a semi-permeable membrane, the pores are so small that it allows only the solvent molecules to pass through. No solute particles will go. Now let me tell you some examples of a semi-permeable membrane. Inner egg cell. After removing the hard part made up of calcium carbonate, the inner soft cell is called inner egg cell, which is an example of semi-permeable membrane. Inner animal membrane. When the animal is fatter, the outer skin when is removed, there is an inner white part that will act as semi-permeable membrane. Inner animal membrane, particularly pig membrane. You must have seen fish. The fish bladder will act as a semi-permeable membrane. In addition to these three, also you can have parchment paper, or cellophane. These are the examples of semi-permeable membrane. Here I am to say the pores are so small that it allows only the solvent molecules to pass through it, not the solute particles. Now, what is osmosis? Let me write down the definition of osmosis. The movement of solvent towards the solution side through a semi-permeable membrane. Is called osmosis. The movement of solvent towards the solution side through a semi-permeable membrane is called osmosis, or the movement of solution from lower concentration to higher concentration through a semi-permeable membrane. Through a semi-permeable membrane. Is called osmosis. The movement of solution from lower concentration to higher concentration through a semi-permeable membrane is called osmosis. The two definitions I have told you: the movement of solvent towards solution side. If you take Solvent means pure water, and solution means let it be sugar solution or any common salt solution. Here this movement of solvent towards solution side is called osmosis through a semi-permeable membrane. The second definition is the movement of solution from lower concentration to higher concentration through a semi-permeable membrane is also called osmosis. In this case also, the semi-permeable membrane allows only the solvent molecules to pass through. So let me demonstrate the osmosis with the help of one experiment. This is a beaker containing pure water. Here inside the long neck funnel, this is a long necked funnel. Here I have taken sugar solution. The moment, and here the mouth of the funnel is tied with a semi-permeable membrane. This is further clamped with a clamp stand. With the help of a clamp stand, the long-necked funnel is tied and it is suspended in a beaker of water. The beaker contains water and the long-necked funnel contains sugar solution. The mouth of the funnel is tied with the help of a semi-permeable membrane. Then the moment it will be dipped inside, its level will move up. This is the initial position. This is the initial position and this is the final position. The initial height of the solution inside the funnel is up to this extent. The moment it will be dipped inside pure water, it will go up, it will move up to this extent. Now why this happens? Because there is some pressure here. Because there is some pressure here. The moment of pure water from the beaker will move towards the solution side into the funnel. So the moment of solvent towards the solution side is termed osmosis and it takes place with the help of a semi-permeable membrane. Semi-permeable membrane is tied here. The moment I shall hang it with the help of a clamp stand. its level will move up, its height will rise because there is a pressure here. Solvent molecules will pass through the semipermeable membrane here I have marked towards the solution side and the height will rise. Now question arises, to what extent it will go on rising? To what extent it will rise? Here there is some pressure, and if I shall keep my tip here, I shall feel some sort of pressure. Now the excess pressure which is required just to stop the flow of the liquid from lower concentration to higher concentration through a semipermeable membrane is called osmotic pressure. So I have used here osmotic pressure. So osmotic pressure is defined as the excess pressure which is required just to stop the flow of the liquid from lower concentration to higher concentration through a semipermeable membrane is called osmotic pressure. Let me write it. The flow of the liquid from lower concentration to osmotic pressure, let me write in a different way. The excess pressure which is required just to stop the flow of the liquid from lower concentration to higher concentration through a semipermeable membrane. So osmotic pressure is defined as the excess pressure which is required just to stop the flow of the liquid from lower concentration to higher concentration through a semipermeable membrane is termed osmotic pressure. Are you following osmotic pressure? What is that? Because here there is a pressure, so the liquid will move, the solvent will move from lower concentration to higher concentration through a semipermeable membrane. Now question arises, to what extent it will rise? If I shall keep my tip here, I shall feel some pressure. The excess pressure which is required just to stop the flow of the liquid from lower to higher through a semipermeable membrane is called osmotic pressure. Now two solutions, if you have the same osmotic pressure, it is called isotonic solution. Two solutions having the same osmotic pressure is called isotonic solutions. I shall now tell you the laws of osmotic pressure. First law is Vant Val's law. The first law is Vant Val's law. The osmotic pressure is designated by the symbol pi. This pi is directly proportional to the concentration when temperature is constant. So Vant Val's law says the osmotic pressure is directly proportional to concentration when temperature is constant. Now this pi is proportional to C is the concentration. If 1 mole of the solute is dissolved in V liter of the solution, then this is 1 by V, or pi is equal to constant into 1 by V, or pi V is equal to constant. This is equivalent to PV is equal to constant, which is Wahl's law. In case of Wahl's law, we have read PV is equal to constant, and here I have shown pi V is equal to constant. This is Vant of Wahl's law. Now the second law is Vant of Charle's law. Here, the osmotic pressure pi is directly proportional to the absolute temperature T when concentration C is constant. This is equivalent to Charles law in gases. Now, combining these two laws, Vant of Wahl's law and Vant of Charles law, I shall tell you here. We have read in Vant of Wahl's law, pi proportional to C. In Vant of Charles law, pi proportional to T. Combining these two, pi proportional to Ct, or pi is equal to a constant R Ct. See the concentration, where if L moles of the solute is dissolved in V liter of the solvent, then pi is equal to R N by V into T, or pi V is equal to nRT. This is equivalent to PV is equal to nRT, which is ideal gas equation. This is ideal solution, combined gas equation for liquid by applying laws of osmotic pressure. Now here R is universal gas constant. In case of gas laws we have read, where the value is 0.0821 liter atmosphere per degree per mole. The value of universal gas constant is 0.0821 liter atmosphere per degree per mole. But in case of liquid, the value is 0.0815 liter atmosphere per degree per mole. This is almost similar. So, laws of osmotic pressure is clear to you all. Now, I want to tell you one thing here. Isotonic solution, and there are two types of solutions, hypotonic and hypertonic. I shall explain these two terms with the help of suitable examples. If I shall take one egg by removing the hard shell made up of calcium carbonate and dissolving it, then this is the initial position of the two eggs, but the hard shell is removed, and now it is dissolved in concentrated solution of sodium chloride. After some time, you will find that the egg is shrinked. Egg is shrinked. Let me do it with the help of dotted lines. In this case, initial position of the egg was this. It is dipped in very dilute solution of NaCl so that its size will be enlarged, will be doubled up. Egg is swelled. In one case, I have cited the example of hypertonic. The other case, I have cited the example of hypotonic. Now, hypertonic and hypotonic is clear. Osmosis is clear to you all. I hope osmosis and laws of osmotic pressure, I have tried my best to clarify your doubts. But my point is, if you like my topic, then you give a liking comment, or if you are not satisfied, then give a comment in the commentary section. Thank you all. Thank you again.